start streaming and it's on. Are we live?
Yes.
I think we're live. Yeah, so welcome everybody. This is my first presentation on a topic that I've been trying to get my hands on for a long time, and it's about shaders. So I made the title a little bit more interesting, so maybe people will join. So let's get started then. I will give you a brief summary of what I'm going to talk about today. If you don't know who I am, then I'm going to talk a little bit about myself, where it all started with shaders. How did it go with my first shade, and what are some examples or applications I made for it. So I will get started now. So who I am a software engineer. I've been doing that for almost 8 years now, and yeah, I'm getting a little bit tired. So I'm moving on to my old dream, making video games. But right now I'm just a guy getting some game developer skills, so it will be some time until I make real progress in that field also. I am a minimalist, so I like to make things a little bit abstract and simple. I have become more or less a good beginner in pixel art, and I am a retro game enthusiast, so I am all about retro games. I really love that era. I think I will stick with that for a long time. What do I usually do? I do Java, JavaScript, Python, and C# when Unity comes around, just to keep my C# skills sharp. I do pixel art most of the time. I do mockups, I do tributes just to practice, and mainly just for fun, because pixel art is something that I really enjoy. And I make up mockups of games that I may never finish. I think making mockups is fun. Maybe that is a way to attract people to get a team. But most of the time I realize that these mockups or game ideas, they never see the light of the end of the tunnel. And recently I'm making horrible sounds with sine waves. I am using programming to make sounds and sound effects. So yeah, I'm ruining music also. So where it all started with shaders, as it always has been, it's always been a struggle for me. So I started getting interested in shaders, trying to find out what can I do from the programming side to make my games or make my game ideas look more cool and advanced. And eventually I tried doing it my own way, and yeah, soon enough I started finding myself like I'm hitting a really big wall, because I was basically killing the machine, killing the overall performance of the game. So yeah, I needed something else. I needed something different. So I decided to make a stop and think about it. Just like, yeah, I cannot reinvent the wheel, so I knew I have to accept to myself that I know nothing. That there has to be a more efficient way to put cool effects in a game. I mean, it's 2017. There has to be different ways. It cannot be that difficult. So I did a little bit of research on an old advice a friend of mine gave me, and it's like I should use shaders for doing these complicated effects. So yeah, the confession that I had to make is that I was using a lot of nested for loops to change each pixel of the screen. I thought I could get away with it since I was making low resolution pixel art, but yeah, when it comes to several items and objects, you know, interacting in a screen, then it becomes undoable. So I had like some example of a tweet that I made some time ago, and here I'm changing every pixel of the screen, but from this canvas, and I'm doing some interesting effect, but this is actually very heavy computing wise, so it's not doable to incorporate that in some sort of game logic. So yeah, as much as this works and it's only 140 characters, it's not feasible to be incorporated into a game idea. It looks nice, I must say, but uninteresting, at least for me. Yeah, maybe I have a fetish for patterns and fractals, I don't know. But so yeah, so I needed to understand, to know what I can do better. So my intentions were knowing more about shaders, understanding why are they so efficient, and where can I apply them, so it's not an overkill. Like, yeah, I mean, I could make a shader to make an alpha blend, but that's already incorporated in most engines. So, and there are several examples. And the first challenge that I face when trying to understand shaders is like you need to know, you need to have your math together, like really have to have some understanding about vectors, about mathematics, and about rotations and all this stuff, or you're gonna have some really hard time trying to create your own shaders ideas. Another concept is like you have to think in parallel, because shaders are executed in parallel. It's like a different paradigm there. Like it's not like sequential. And you have to think in vectors. Everything about shaders is about vectors. No? So what did I did most of the time while exploring how to use shaders and how to apply them? I was totally confused. I mean, I was trying maybe to solve simple problems with a hammer that when it's only require a few lines of code, but I still try to enjoy the process of not knowing nothing and then trying to grasp a new concept. It's kind of fun for me. This is how I spend my free time. So I think since last presentation, not much has changed. I still have issues. Like I mean, having a full-time job and then coming back to the few hours that I have after work, I am tired. I have lack of focus, and to make it even worse, I'm a slow learner, and I never did shaders before, so I guess I'm doomed. Yeah, but I never gave up, so I continue. Started from the very beginning. What is a shader? The shader is a powerful tool to control stuff and how it's rendered by the graphics card. Shaders are programmed with a set of instructions that are sent directly to the GPU, and they are executed in parallel for each pixel of the screen, which is awesome. Something that it doesn't happen when you're doing it like in series. Like if you do it nested for loops and try to, change, verify each pixel of the screen, then it's gonna take a while, especially if you have like more than 1 million pixels. Then imagine that. I mean, there can be some clever multi-threading techniques, but at the end, all these threads have to be synchronized at some point. So, yeah, it's not doable. This is why we have GPUs, and the model is somehow like this. Like for each pixel of the screen, there is a small tube, and all the instructions that are there are executed in parallel. So this is why shaders are so powerful, and this is only for 2D. So I think in another presentation I will talk about 3D shaders, but right now it's only for graphics and 2D graphics. The cool thing about shaders is like they free the CPU time to do more logical and critical tasks. So you can separate some of the most complex graphical operations, send them to a shader, and let the CPU handle other important logics, like maybe some data processing that you need to do during your game, and yeah, I know, you name it. It's a big world out there. So there is an infinity of applications. So this was my first struggle. This is what my friend told. This is why my friend told me about that I should go into shaders at some point, because I was trying to animate this in a huge screen, and I was never able to make it more further than 500 pixels by 500 pixels without the machine beginning to feel the pain. So cellular automatas are an ideal case for parallel computing. So that was like my motivation to learn the shaders a little bit. The thing is, like, for integrating this shader in a game project will make this interactive cellular automata like scalable and responsive in a video game, and I'm so much looking forward to play around with this idea. But I try to keep it more simple. I try to bring it home, like more to earth. I also I just made some calculations, like for reference. For example, if you take into account that some of these animations here are 200 by 200 pixels, that means that times 60 frames per second, it will be like, you know, having to update like 2.4 million pixels per second. It's like, it's evident why everything was, you know, getting so crushed. So yeah, implementing that with a shader is the way to go. So I decided to start a little bit simple, like where do I start with my first shader? Like, first of all, since I've been around GameMaker and I've been around WebGL, I went with the GLSL, that is like the OpenGL shading language, which is mostly like a high-level language based on C. It was basically created so to allow developers to get more control of the graphics pipeline. And since it's a standard, basically, I mean, I have seen that from WebGL to Unity to GameMaker, the same shading language syntax doesn't change, and with little effort, you can actually port some of your shaders from HTML to Unity or to GameMaker. I guess also to Unreal Engine, but I haven't explored that too much because my laptop sucks. Yeah. So more or less, it's like the two main components of a shader are like a vertex shader and a fragment shader. When you're working with graphics and images, you're mostly interested in the fragment shader. When you're doing some 3D stuff, then yeah, you will go here, but yeah, not in this presentation. So a vertex shader takes the data from the mesh. You know, a mesh is composed by triangles, and all this information from the mesh is sent to the fragment shader, and from there you get all these little squares that are actually going to become an image on the screen. Yeah, depending on the mesh size, then it also relates to the amount of fragments that you will get. So here is the part when I have to show you some sample shaders that I made. I think the first concept that you need to understand is how UV coordinates work. I mean, a pixel shader needs some way of knowing in which pixel it's currently working on and which pixel do you want to sample in texture. Also, it's like the UV coordinates is like your guidance along this along the texture. Sometimes you might even have like a bigger image, and you can just render portions of an image, so you can play with this to create some interesting effects. At the end, you have to respond a 4-dimensional vector, like I will show you in some of the examples. In this vector, this result vector, you manipulate basically the three channels, like RGB and alpha. So, moving away from the cellular automata, I decided to take one simple use case. I wanted to make darkness, like the darkness effect that I will get, for example, using this. This is a program called Dithering Machine. I wanted to create some sort of darkness like this, and I wanted to make the light below to make it feel more dynamical. I didn't want to use sprites. I wanted to be something that it looks more realistic, but keeping the pixel art kind of effects. So basically, the idea was that I would make these concentric radial gradients and then add a filter to these circles to make it more like pixel art using some Bayer matrix. I wanted to manipulate each of the pixels so they follow certain patterns. This was my idea at the beginning. So the first experiment that I made, I first wanted to get some shader working on, and this was my hello world. And it's kind of, this is all that it is for a shader actually, and you can make a lot of interesting stuff here. Let's start something here. For example, if you add the time variable, you can already start seeing like how things change during time. And this is actually running on all the canvas, and it's doing it blazing fast. If you were doing this in series, then probably the whole browser might be crying at the moment. So this was my hello world. I got the concentric rings that I wanted, but still I was really far from what I wanted originally. So I kept doing some more experiments here. I started like moving into that direction, and you can see that this is what I said, that at the end with a fragment you need to respond a 4-dimensional vector. So you make all this all these effects. I mean, it depends maybe on your game idea or whatever you're trying to do. You can start playing with math functions and vectors and colors and create some cool effect. Here I have my circles. I use this as a base to get my shader going. Then I wanted to play with the idea of a light. I tried to focus. I break this problem in different things: how to make the concentric circles, how to make the light, and then hoping that I can bring all this together. So at first I have a light now. So I decided that if I make this light, okay, it has to be. Maybe I can make this light that the amplitude of the equation is not that big. So let's not. I mean, you can play with this with these values here and make all sorts of different effects. So yeah, basically that I was playing with this idea. Then then I got, okay, how do I make the at this point I didn't have the idea of the Bayer matrix, so it was really hard to make the pixel art kind of effect. So I started with a simple hello world of making a checkerboard around a circle, and making, obviously doing that the center it was more illuminated and it gets darker on the sides. So it took a little bit of effort here, but I managed to get that part, but it was still not what I wanted. So my second attempt, it's kind of what I wanted in the image, but it obviously gets more messed up. So at this point I was really frustrated, because I realized that I was trying to do something very hard. It's like recreating the whole pixel art kind of effect. I mean, if I already have the concentric circles, all that I needed to do is to apply the Bayer matrix effect, and not do the whole pixel art kind of effect myself. So I remember the wise words from Nele, that she said to me that I should not do everything by myself. I should rely on the tools. And yeah, so on my second attempt, it looked like this. So you can see now that there is a light there in the background, and this is what I wanted to achieve. And I was happy with the effect, but then I started asking myself if it's not an overkill. So I left the code there as an example, and decided to make, now that I have this pixel art filter, I try to explore different opportunities to use shaders, and I decided to make a retro filter for my game. So for example, this is the game that I have here. This is how it looks like without a filter. It's just like a simple mockup. Then I decided to apply the same theory into GameMaker using shaders and apply a filter to the same, well, not precisely the same game, but it's the same creature, the same background, trying to capture like this old retro kind of effect. But yeah, I was putting too much effort on making this game look like crap. So I decided to go for something more traditional, like chromatic aberration, and this is the effect. It looks more kind of, it has a different feeling of like old TVs, you know, when we have like these the big TVs with with this rays, this phosphorus screen that sometimes created this weird effect on the sides if the signal was kind of broken. So it is a filter, and it's not and it's very efficient actually because it's running on a shader. So there is some things that you can actually do with these shaders to make your looks kind of look more interesting. If you're not into retro kind of style, I don't know then, but there is a lot more things that you can do. So my interest with shaders kept on going, and I started trying other tools, like for example ShaderToy. In ShaderToy there is a lot of, it's a big community, there is a lot of stuff going on here. I don't know why this is broken. This is not supposed to be this broken. Wait a minute. Ah, okay, yeah. Yeah, for example, I was playing with sine functions and discovered some cool stuff here. Like, there is some, like you can play with this, and this is actually very efficient. As you can see, it's running at 44 FPS, and I use this to create some sort of animation, like the background is kind of some space or something like that. But I basically just let me just change here. Yeah. So I don't know, there is a lot of things that are going on with this. You can basically do even some perspective animations here, like you can create some fake 3D stuff and project objects there, make a lot of interesting effects for photography, for whatever you can think about, or you can go really hardcore and make a procedurally generated fractal, you know, labyrinth, which is actually cool. But I don't know what kind of wizardry you need to learn to create some such effect. I mean, you can see the code here, but even with the code here, I'm still not able to grasp what the hell is going on. But shaders are very powerful tool, and at some point, if you're interested in this, it's like you should consider giving it a try. There is a lot of things you can benefit from. Yeah, but I wish this was mine, but it's not. What else? What else I have to show? Yeah, I talk a little bit about chromatic aberration. Yeah, I have the definition here. It's just you can see there that it's produced by different wavelengths and different angles, and yeah. So another thing that I did with GameMaker was trying to make an experiment. I wanted to make this light effect. This is done with a shader. Just use the light example. It was just a raw example. I wanted to create some sort of light, like a torch. But sometimes you can see that it might be an overkill, and you can also be happy just doing, like, keeping it simple. Like, yeah, no, it's a torch. So I think there has to be some aesthetic guideline when you're doing this kind of effects, so you don't break up the whole the whole design of the game. Because while shaders can give you a lot of power, it can also break up your initial idea or your design. So yeah, and yeah, so I made a handmade torch at the end, and yeah, thank you for listening. Any questions?
So, what are your next plans?